The empirical formula, Mr. Sams.
Empire.
The Empire Strikes Back. Where's Luke?
I'm right here.
Oh, are you?
I am Luke Skywalker.
So am I like Darth Vader?
Yeah. You need a lightsaber.
Yeah, I need a lightsaber, so I've got the pin, so I can do that. Hey, we're going to talk about the empirical formula today. What is that? Empirical formula.
Empirical formula. That's the lowest whole number ratio of the elements in a compound.
Okay, so let's write that down. Actually, let's write that down here. So the definition of an empirical formula is the lowest, what is it?
Whole number ratio.
Whole number ratio in a compound.
Yep, of the elements in a compound. So let's say we had glucose, C6H12O6.
C6H12O6.
That is not its empirical formula
because
we can divide
that.
all those numbers by. It's kind of like reducing fractions. Yeah.
So
H2.
H2O.
Oh, right.
Yeah.
Exactly.
So this right here is the empirical formula. So EF, let's call it.
Okay.
Of this, and this is what we call the molecular formula. And we'll talk more about that
in the next lesson.
Yep. But we're trying to find the simplest whole number ratio.
Right.
And it's basically taking that percent composition thing that we did last time and
going the other direction.
Going backwards.
Yeah.
So that's what we're going to do. So it's kind of a cool little pneumatic, Mr. Sams.
Yeah, percent to mass.
Percent to mass.
Mass to mole, divide by small, times to whole.
That kind of rhymes.
Percent to mass to mole, divide by small, times to whole.
Now what does it mean?
I don't know, but it's in a poster on our walls. If you ever forget, you can look at there. Okay, percent to mass. A lot of times these will be given to you as percentages.
Okay.
Okay, so basically we're just going to take that, and we're going to assume we have a 100-gram sample, so we just turn those percentages directly into grams. No conversions, you just change the percent sign into grams.
Good.
Okay. Then the mass, we're going to convert those into moles, mass to moles using the molar mass.
Good, good.
Then we're going to look at the smallest one, so divide by the small. Whichever of those moles is smallest, we divide them all by that number.
Okay.
And then if those are not whole numbers, which sometimes they are, sometimes they're not, we divide by a number to get them all to be. I'm sorry, we multiply by a number to get them all to be whole numbers.
All right, I think we should just try it.
Let's just do it. It's easier to see. Remember the pneumatic and do the examples.
Okay, I can do that. Now here is the problem.
Okay.
Calculate the empirical formula of a compound,
Yep.
67.6% mercury, 10.8% sulfur, and the compound also contains oxygen.
What's the percent of oxygen, though?
Well, I think we'll have to subtract from 100.
Oh, that's right, because they always add up to 100.
All right, let's get a blank screen.
All right,
to work
let's
this.
do that.
Okay, I think I need a blank
All
screen.
right, 67.6 grams
watch how I
of
set
mercury.
this. If I've got mercury, now it said 67.6%, so I'm going to write 67.6
grams. That's the percent to mass step.
And then when I had S, right?
10.8%.
So that'll be 10.8 grams. That's I'm doing the percent to mass in my head.
Right.
Really hard, guys.
Yeah.
You just say
you take the percent sign
and you make it a gram. Tough.
Right.
And the oxygen is a little tricky because you have to subtract from 100
minus that.
So I'm going to take 100. I got my little. We kind of made the calculator smaller because we needed more room. So I'm going to take 100.
You had to turn it on.
Yeah, I forgot to turn it on. Minus 67.6 minus 10.8. All right.
21.6%, so 21.6 grams. All right, so that's the percent to mass.
So now we're going to just do a mole conversion, grams to moles. So grams of Hg in 1 mole of Hg. Well, I just look at my periodic table. My periodic table.
200.59.
200.6. I'll say that, okay?
Okay.
Okay, let's just set them all up. What do you think?
Yeah.
I like to do it this way. Grams of S, 1 mole of S, and I don't even need the periodic table because I know that it's 32. And oxygen, I hope none of you know this, it's 16 grams of oxygen in 1 mole of oxygen.
Yep.
Now, don't get this confused with O2.
No.
Because we're doing it one element at a time.
Right.
So now I'm going to get the calculator out. Let's do this. 67.6 divided by 200.6 equals. Okay, I get 0.337 moles.
Okay.
Now I'm going to do that with the S. So 10.8 divided by 32 gives me 0.33, I think it's 8.
8, yeah.
Moles. Pretty close to the other number, isn't it, Mr. Sams? Okay, and then I'll take 21.6 divided by 16, and that gives me 1.35.
Okay.
So percent to mass.
Mass to mole.
Mass to mole.
Divide by small.
Divide by small.
All right, so what's the smallest one?
I think 0.337.
So we divide them all by 0.337.
I don't have any calculator. That's a 1, Mr. Sam's.
One of them will always be 1.
0.337, yeah. And this is going to be close enough to 1. I can go with that.
I think we're going to call that 1.
Even though, if you divide it into a slightly different number, we're getting a rounding issue here.
Yep.
0.337. Now that I don't know. Actually, I think I do. But we're going to say 1.35. I believe it's 4. Divided by 0.337. And I get close enough to 4.
4.0059. Is that close enough to 4?
Yeah. So essentially that means there's 1 HG. That's HG. There's 1 S and there's 4 O's. So we'd say O4. So the real form is HgSO4.
That would be mercury
2-sulfate.
2-sulfate.
Yeah. Okay. Let's do a different one.
Okay.
Okay. This would be an interesting chemical. I think we might have seen this chemical before. What is the empirical formula? All right. When you have 6.256 grams of carbon, 1.392 grams of hydrogen, and 8.352 grams of oxygen. Now, guys, what you're going to need to do is definitely copy this down. Don't just try and watch and say, oh, I get it. You've got to copy these examples down.
Go through the process with us.
Yeah, go through the process with us. Yeah.
Humorous.
All right, so we've got 3 elements,
right.
C, H, and O. So I'll notice it's a CHO compound.
Yeah.
Yeah, all right.
6.256 grams.
Okay, hydrogen
No, wait,
is...
these were not percentages.
Oh, yeah. Can we do this?
I thought it was percent to mass. We don't have percents. What do we do? What do we do? Oh my gosh! I don't know what to do! Percent to mass!
Mr. Sams,
What?
we can skip that first step.
Why?
Because it says percent to mass.
Oh!
We have the mass.
Grams are already mass.
So we get to skip step 1. This is easier.
Oh, yes.
I like easy.
Sorry, I panicked. It wasn't what I learned.
Oh.
You didn't teach me this!
Oh, well, now I just did.
Okay.
Just don't relax. Take a breath.
1.392 hydrogen.
I had a banana earlier.
I know, and I turned it into a brownie. It was
know.
really good.
All right, so but the sugar high must be gone.
Something.
All right, well, how much hydrogen we have?
1.392.
1.392 grams. And oxygen was?
8.352.
8.352. Okay. So I'm going to just convert that to moles. Carbon weighs 12 grams in 1 mole. I'm not going to I'm going to be a little naked on this one because I need the space on the screen.
I'll keep my eyes closed.
1 gram in 1 mole. Should I take my shirt off? No.
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 1.392. But I'm kind of ripped, Mr. Sams.
Keep telling yourself that.
Yeah. So I could do the middle one. I didn't even need like a calculator on that one, Mr. Sams, because it's divided by 1. I left the shirt on. You can open up your eyes.
Okay.
Okay. And I need a calculator on this one, but I know it's 16 grams in 1 mole here. All right, so 6.2, whatever. 6.256 divided by 12. About 3 or something like that. Or no, I'm backwards. All right, 0.521. And this will be the bottom one, 8.352 divided by 16. What is that?
I don't know.
Whatever, 16. All right, 0.522. Ooh, I kind of see a pattern, the 522s. Okay, this should be 0.521 is the smallest
that
one.
Is.
Divide by small, 0.521. 0.521.
Okay.
This first one is 1. This last one is 1. Okay, now that's not so. All right, 1.392 divided by 0.521 leads off to 2.67.
2.67. Interesting.
2.67.
Okay, yeah. Okay, so here's
percent to mass.
Yep.
Mass to moles. Divide by small.
Times till whole.
Oh, we didn't do that last time.
The last step, they were already whole numbers. We had 1, 1, and 4. Here we don't have a whole number. So here's a few little tricks when you need to multiply by whole numbers. If one of your numbers ends in 0.5, you're going to multiply by 2.
All right, something 0.5 times it by 2.
Right.
Okay, write this down, guys.
Yes. If something ends in 0.3 or 0.33 or 0.66, you multiply by 3. And that's probably all you're going to see.
Yeah.
If you saw 0.25, you could do by 4. But these
why
are
this works, guys, when you say 0.5, that's 1/2.
Yep.
When you're multiplying by the denominator, which is a 2, that'll make that
then you get a whole number.
And 0.33 is 1/3. Timesing it by 3 makes it a whole number.
Yep.
And 2/3 is 0.66, 0.67, whatever. You times that by 3. That's why this is working. So let's take a look.
So let's go
we
back.
ended in 0.67, Mr.
Yeah,
Sands.
let's multiply everything by 3.
Now, this is a mistake so many people make. It's everything times 3. Not just the 2.67, but the 1. So take 1 times 3. That's 3. 2.67 times 3. Now, I'll put it in the calculator, but you really, hopefully, you can do that on your own. 2.67 times 3 is 8.
8. And that's close enough to a whole number.
Yeah, you want to get to a whole number, and maybe neighborhood, right?
Yeah.
And this will be 3.
Right. So carbon, we have 3 of them. So C3.
All right, let me just clear that out.
Okay.
So there's 3 carbons.
Yeah.
There's 8 hydrogens, and there's 3 oxygens.
C3.
C3.
H8.
H8O3.
O3. Hey, that's that glycerin stuff.
That's the stuff that exploded in your classroom the other
It
day.
didn't explode.
Well,
it was
it
strongly
smoked.
oxidized and produced a lot of smoke.
Yeah.
And our faulty fume hood did not vent it properly.
That sounded like you talked to the lawyers last night.
No, not lawyers. That was just my official statement to the administration, because that's exactly what happened.
That is what happened.
I actually didn't even know the fume hood didn't work properly until the fire department came and
said it didn't work.
And said, hey, it's not working properly. You need to get it fixed. So they fixed it today.
Yeah, they were very quick about fixing
They were.
that.
The fire department was
we had a
great, and so
staff.
was our facilities guys. Yeah, they're great.
All right. So, guys, I want to just review. Very important on this last step. Everything's multiplied by 3. And use that chart that we have right here to help you understand what to do.
Yeah.
Okay? All right.
Great.
All right. One more, I think. Yeah?
Next time.
All
That's
right.
it.
Bye.